Hi, this is Mrs. Freeman, and today we're going to take some notes on dividing a polynomial by a monomial. So we have three steps we're going to look at. So step one says separate the polynomial so that each element is being divided by the monomial. So we're going to separate. Then step two says we're going to simplify each piece. So it says divide the coefficients and subtract the exponents. So if we were looking at something like 7x to the fifth, 7 is your coefficient and 5 is your exponent. And then the last step says to combine like terms if possible, which we did that right before break. So let's look at some examples. So the first example is 3x to the seventh minus 6x to the third, all divided by 3x squared. So step one was to separate the polynomial. So we're going to start with the very first term, which is 3x to the seventh, and we're going to divide it by the bottom term, which is 3x squared. Then we have a subtraction sign here. Then we're going to take the second term, which is 6x cubed, and divide it by the bottom term, which is 3x squared. So all we've done is separate them. Now we're going to simplify. So we're going to divide the coefficients, which are the big numbers. So 3 divided by 3 would just be 1. And then we're going to subtract the exponents of like terms. So this is a x to the 7th and x squared. So we're going to subtract 7 minus 2 is 5. And we can do that because those are both x's. So x to the 5th. I'm going to bring down this minus. Do the same thing over here on the right. So we'll divide 6 divided by 3 is 2. These are both x's, so we can subtract the exponents here. 3 minus 2 is 1. So we have 1x to the fifth minus 2x, and those are not like terms, so that's our final answer. So let's look at example 2. So example 2 says 12x to the 10th minus 6x to the 6th plus 2x to the 5th, all divided by 2x cubed. So the first thing we're going to do is to separate them. So we're going to take the first term, which is 12x to the 10th, and then the fraction bar means division. The bottom term is 2x cubed. Okay, and then we're going to go to the middle term. So negative 6x to the 6th divided by the bottom term, which is 2x cubed. And then our last term, we have plus 2x to the 5th divided by the bottom term again, which is 2x cubed. Okay, so now we're going to divide the coefficients. So on the first term, we'd have 12 divided by 2, which is 6. These are both x's, so we can subtract the exponents here. 10 minus 3 is 7, so 6x to the 7th. Then go to the middle one. So we have negative 6 divided by 2. Divide your coefficients, so negative 3. And then we have x to the 6th and x to the 3rd. So we'll subtract our exponents. So 6 minus 3 is 3. So x to the 3rd. And then our last term, our coefficients, 2 divided by 2. So that's positive 1, so plus 1. And then our exponents. So we have x to the 5th and x to the 3rd. So subtract these. 5 minus 3 would be x squared. And we don't have any like terms. So this is our final answer. 6x to the 7th minus 3x to the 3rd plus 1x squared. So example 3 is a little bit different just because you have two variables here. So we'll start the same way. So step 1 is to separate. So the first term is 45a to the 12th b divided by the bottom term, so 15a squared b. And then the second term we have a minus, and 90a to the 11th b to the 4th divided by the bottom term again, which is 15a squared b. Now we want to go back and divide each part out. So if we go back and look at the first one, we have 45 divided by 15 for our coefficients, which is 3. And we'll look at our a's, a to the 12th and a to the 2nd, we'll subtract those exponents. So 12 minus 2 is 10, so that gives us a to the 10th. And then we'll look at our b's. So these are both like exponents of 1. So since 1 minus 1 is 0, that means there's not any b's left. These will just cancel each other out. Then we'll look at our second term. So our coefficients are 90 and 15. So we'll divide these. 90 divided by 15 is 6, and we have a minus or subtraction sign here. So minus 6. Look at our a's. A to the 11th and a to the 2nd. So that gives us a to the 9th. And then our b's. So b to the 4th, and this b is like a 1. So 4 minus 1 would give us 3. So b to the 3rd. And then that's our final answer, because these are not like terms. So last example, this is a you-try. So I want you to pause the video, try this one on your own, and then come back and make sure that you have it correct. So first step is that we're going to separate. So we're going to take the first term, so 7x to the 10th y, divided by the bottom term, so 7xy. Then we're going to go to the second term, so negative 35 x to the 7th y to the 4th, all divided by that bottom term again, 7xy. Then the next one, we have plus 14 x to the 5th y to the 12th, all divided by that bottom term again, which is 7xy. So now we're going to actually divide. So go back to the first term, divide our coefficients. 7 divided by 7 is 1. Take a look at your x's. So x to the 10th, and then this is like an x to the 1st on the bottom. So subtract 10 minus 1, so that'll give us x to the 9th. That's a 9. And then look at our y's. So this is like y to the 1st and y to the 1st. So 1 minus 1 is 0, so no y's. The y's cancel out. Then we'll look at our middle term. So divide our coefficients. So negative 35 divided by 7. So negative 5. And subtract our exponents. So x to the 7th, this would be like x to the 1st. So 7 minus 1 will give us x to the 6th. And then look at our y's. So y to the 4th, same thing, this would be y to the 1st. So 4 minus 1 will give us y to the 3rd. Then our last term, divide the coefficients, 14 divided by 7, so plus 2. Look at our x's. So this is x to the 1st on the bottom. So 5 minus 1 will give us x to the 4th. And then look at our y's. So y to the 12th. This is y to the 1st in the denominator. So subtract 12 minus 1 will give us y to the 11th. Then this would be our final answer, because there's no like terms here. So 1x to the 9th minus 5x to the 6th y to the 3rd plus 2x to the 4th y to the 11th.